Back to another video. After such a long time have I uploaded a video. I have never gone this long without uploading a video. I think the last time I uploaded one was on the 2nd of September, and it's been 10 days since then. This is the longest I have gone without uploading a video. And the reason for that is because my pen, the stylus that I write with, was spoiled. It basically didn't work. And the battery needed to make it work again was not available in stores. It was a different type of battery. And finally, I have got that today. And my pen is working again. So now I can write and make these videos for all of you. Hopefully, you guys appreciate this. Now, we are here back with a organic chemistry concept. As I was continuing from my previous video, I've been doing organic chemistry videos for the past 3-4 videos now. I did electrophilic substitution last week, which was a strictly HL topic. And now I'm going to be doing free radical substitution, which is an SL and HL topic. It's very, very simple. I know it sounds all complex and very technical, but don't worry about it. It's actually very easy. And you could think of this kind of this reaction as sort of an action story with some adventure and some revenge. And I'll tell you what I mean. We'll get to that part. Now, in front of you, there is this equation where we can see that methane reacts with chlorine to form HCl plus CH3Cl. Now, this is a fairly straightforward reaction. And what we can see has happened is that methane has traded one of its hydrogens for chlorine, and then chlorine has accepted the hydrogen, so it becomes HCl, and this chlorine has gone over to methane. But this is actually not as simple as this. There are multiple sub-steps that happen for this entire reaction to actually take place. And this is exactly called free radical substitution. This reaction is an example of free radical substitution. And like I said, this is the final reaction. There are many other sub-steps that happen for us to get to this whole stage, for us to get these products. So there are many sub-steps that happen, and exactly what we're going to discuss today are those sub-steps. And there are 3 main sub-steps. You may have heard of them, you may not have heard of them, but let's discuss them. So the first sub-step is something called initiation. I'm not sure if I'm spelling that correctly, but hopefully I am. So initiation, as you can probably tell by the name, is the very first step in the free radical substitution. It is a step which is responsible for producing the radicals. What is a radical? A radical is basically a highly reactive species which is reactive because it has an unpaired electron. So it is reactive because it has an unpaired electron. And remember, unpaired electrons make species very reactive. So the first step is to produce a radical, and that is the initiation step. And an initiation step looks something like this, where Cl2 becomes radicals. Now, what are these dots? What is this? These dots signify the unpaired electron, and these are your radicals. So this is how we denote radicals. Remember, radicals are highly reactive species, and they are reactive because they have an unpaired electron. So Cl2 forms these two radicals, right? So when Cl2 was together, it looked something like this, right? Cl, and they shared these electrons between them. So this was the covalent bond. But then what happens is that to produce the radicals, something called homolytic fission happens. Homolytic fission. Homolytic fission. If you can probably tell, homo means the same. So homolytic means that this bond, when it breaks, homolytic fission is the breaking of this bond, and the electrons in this bond, which is one electron given by chlorine and the other electron given by another chlorine, when homolytic fission happens, these both take their respective electrons and go away. So they both break apart, they take their respective electrons and they go away. They're upset with each other for some reason. And this homolytic fission is represented by these fish hook arrows. You can think of them as like half arrows. So these half arrows represent homolytic fission when they break apart. That's how you denote them. So in the exam, if this ever comes, now you know, please do not do this. This would be wrong. You have to do half the arrow, not full. Oops, my apologies. So how exactly does this homolytic fission happen? Well, it happens when we provide some energy for this bond to break. Because remember, atoms, these compounds, they're just not going to break apart for no reason. You have to provide some energy if you want them to homolytic, if you want them to do homolytic fission. So if you want them to do that, you need to provide some energy. And energy comes in the form of a UV light. So UV light. When we provide ultraviolet light, when we provide some ultraviolet energy, then this bond breaks apart and homolytic fission happens. Hopefully that makes sense. So to summarize, in initiation, what exactly does happen? In initiation, we produce free radicals. And these free radicals are highly reactive species, which are reactive because they have a lone pair of electron. And these free radicals are formed by the homolytic fission of, in our case, a halogen, like chlorine, or it could be bromine or iodine, right? So this homolytic fission happens of a halogen, and it produces two free radicals. Now, this homolytic fission is only possible because of the energy we provide, which is using ultraviolet energy. So this reaction that I'm showing you over here, it cannot happen in the darkness. This reaction cannot happen in the darkness simply because we need ultraviolet energy to make this reaction happen. And there is no ultraviolet energy in the darkness. So we need this to be preferably in ultraviolet environments, in areas where there is ultraviolet energy present, perhaps using the rays of the sun, for example. Now, anyways, that is it. In initiation, there is only one step. That's it. That's how simple it is. Initiation complete. This is initiation for you. The next step is propagation. Now, propagation, what do we understand by this word? Propagation is to take something forward, to increase something, or to make something move, right? So propagation is the step where the good stuff happens, where the main thing, the main reactions happen. And that is when one of these radicals, which one of these guys, you can think of them as thugs because they're so reactive, they're so violent, they're like thugs, right? They're going to go and harass some other compounds. In our case, this compound is going to be methane because we have methane in the reaction above, right? Over here. So this thug, I'm going to call it chlorine thug, is going to go and it's going to harass our methane. And because it's so reactive, right, with this unpaired electron over here, it's going to harass it and it's going to steal one hydrogen away from methane. So it's quite violent. So it's going to go and steal one hydrogen away from methane. Methane has 4 hydrogens. This thug, this chlorine thug, which is a radical, is going to come and tell him, you know what, I'm strong, I'm very reactive, give me one of your hydrogens. So methane doesn't really have a choice, it's going to give away one of its hydrogens. So this becomes HCl because chlorine takes one of the hydrogens away. And now we have poor methane, which has become a methyl radical. Because remember, now carbon has one unpaired electron. So this used to be carbon. Carbon has 4 valence electrons. Before it had 4 hydrogens. Now this really mean chlorine thug came along and it took one of its hydrogens away. So now carbon has become a radical itself. It's become a thug as well, right? It's so upset. It's become a thug because it has one of these unpaired electrons. So it too now is extremely reactive and it has become a methyl radical. Now this methyl radical is really angry. It wants some revenge. So it's going to go and it's going to attack an innocent chlorine. This is a normal chlorine. This chlorine is not a thug. It's not a radical. This is a stable compound chlorine. So it's going to go and it's going to attack one of these chlorines. It's going to tell chlorine, okay, give me one of your chlorines. There's 2 chlorines in this. It's going to steal one away. So now it's going to become CH3Cl. Oops, no. And however, since this chlorine has left it, now the second chlorine is injured. It's angry. Now it has become a radical once again. So that's how you see the reaction proceeds. So this is propagation. These are the 2 steps in propagation, and we can keep going on like this forever and ever and ever. But these are the two main steps in propagation. The first step is where the radical you produced in the initiation step attacks your carbon compound or your alkane, right? Our alkane methane, it attacks the methane, and then we form the methane became a methyl radical. And then this angry methyl radical went and attacked an innocent chlorine, and it became, what we got was a chloromethane compound and a chlorine radical. That is propagation. Hopefully that makes sense. The last step is termination. And again, as you can probably tell by the name, termination is when we put an end to something or when something stops. Terminate this, terminate that. So this is where this whole reaction ends, the violence ends, and we have some peace finally. And in termination, there are three ways that termination can happen. The first way is when the chlorine radical, both these chlorine thugs, they happen to find each other again and they become stable, they become happy, right? This is one way that it can terminate. The second way termination can happen is when a methyl radical that we produce in our first step of propagation, it meets a chlorine thug, which we produced in the initiation stage. And these two guys understand the pain of one another and they become friends. So they become a halogenoalkane. And the last step of termination, what can happen is when two methyl thugs or two methyl radicals who have both experienced a very traumatic event where they were robbed by a chlorine radical, they both combine with each other and they form C2H6. So these are the three steps of termination. Termination, to put it very simply, is where you produce no radicals. In termination, you cannot produce radicals. In initiation, we produce radicals. In propagation, we produce radicals, right? We produce HCl and a radical. In the second step of propagation, we produce a halogenoalkane and a radical. However, in termination, this violence ends now. We produce no reactive species, we produce stable species. We only produce such stable species like Cl2, CH3Cl, C2H6, and in termination, we only use radicals. Because remember, if you react a radical and a stable species, like we did in propagation, we reacted a radical and a stable species together, you're always going to end up with a stable species and another radical, right? The cycle never stops. So in termination, where we want the cycle to stop, we only have to react together two radicals. Two radicals give you a stable species. That is your mantra for termination, if you want to help remember that. So hopefully I've made this process clear to you. It is actually very, very simple. Hopefully you have understood it well. But there are many students who don't understand it. I didn't understand it in the first time. So it took me some time to learn it as well. So if you are having a problem with free radical substitution, if you need more help, please feel free to reach out to me in my DMs. I'll be more than happy to help you. You know, we can even hop on a Zoom call and for a few minutes and I can give you a rundown and you can ask your questions. I'll be happy to do that as well. But I just want you guys to understand this process very well because it is important. It comes in a lot of exam questions. Thank you so much for watching. I hope you enjoyed this video. I'll see you in another video with another question. Goodbye and take care of yourselves.